everyone, and welcome to Chapter 5, Section 5.1, which talks about the natural logarithmic function. In this section, we are trying to find the solution for the integral of 1 over x dx.
This function which we couldn't find antiderivative of before because using the power rules, the power should be different than -1. So in this case, we define a new function which we call the logarithmic function and which is equal to ln of x.
This function here has some properties. First, the domain is between 0 and infinity, which means that all the values inside of ln of x should be greater than 0. And the range is from -infinity to +infinity, as we saw in the graph, which is something like that. And all the values here go from, the function goes all the way to -infinity, and again, all the way to +infinity. There is also another property for this function, is that it's continuous. As you can see, there is no every value in 0 to infinity has an image, and also it's increasing as there is no change in the curvature of the function. The function is also one-to-one because it's not even, and every value, wherever, let's say if we take the value 2 for instance, it will have exactly one image by the function ln of x. So the function is one-to-one. And as you can see, the graph is concave downward because, as you can see, the graph looks downward. The properties of the logarithmic function is that ln of 1 is equal to 0 because, as I showed before, the graph of the function is something like that, and the value for which that crosses the x-axis is 1. So the ln of 1 is here. It's the solution of ln of x equal to 0, which is 1. Then we have ln of a times b is just ln of a plus ln of b. ln of a to the power of n is just ln of a because we take the power here we take the power down, and then we just have ln of a. Then we have ln of a over b is just ln of a minus ln of b. This is wrong. So we only have ln of a minus ln of b from ln a over b. We also define the derivative of the logarithmic function, which is the derivative of ln of x, which is 1 over x. Again, why? Because, as we said before, we are trying to solve the integral of 1 over x dx, which is ln of x. So if we were to differentiate ln of x, we'll end up with just 1 over x. And that's what we tried to solve before. And the derivative of ln of u, where u is just another function, is just, let's say that we have ln of u prime, it's just u prime over u, where u is positive again because we can't have negative values for x. There is also the derivative of ln of u, or ln of absolute value of u, which is also u prime over u. We may also define
the number e, which is the solution for ln of x is equal to 1, and e is a particular solution for this this equation here, and e is just a number which is equal to 2.71 something. It doesn't stop.